Welcome to Study Loop.
So we are solving problem 90 now of chapter 17 of Thermodynamics and Engineering Approach, 8th edition. We have airflow with the following initial conditions. The pressure, the temperature, 240, and the Mach velocity. And we want to calculate the pressure, temperature, and Mach velocity after the air has taken an expansion turn here of 15-degree angle. And the method to do this is outlined in page 871 of the book, and in page 874 there's an example problem, which is example number 1712. This example problem is very similar to our situation, so we'll be following this approach closely. And you can see in that example they have this diagram where they have air flowing in and oblique shock waves here, and then it makes an angle theta. This will be the theta in our case, which is 15 degrees. And what we are interested in, Mach A1 is given to us. We are first interested in finding the Mach 2. Mach 1 is given to us, and to find Mach 2, the procedure will be following the procedure in example 1712. So as you can see, we first used the Prandtl-Meyer equation first at near MA1. So they have given us this formula, root of k plus 1 by k minus 1 tan inverse of root of k minus 1 by k plus 1 Mach square minus 1 and minus another term. So what we are going to do is we are going to use the same formula. The k value is still same, it's 1.4 plus 1 by 1.4 minus 1 tan inverse, and wherever you have Mach in that problem, in that example problem, they have the value of 2. We'll be replacing that by our value of Mach, which is 3.6, and this minus then the second part where you have another Mach value, which will again replace by 3.6. and when you solve the new value at Mach 1 using your calculator, you'll find that it is equal to I have solved this, and I see that it is equal to 60.0915 or approximately 60.09. And then following the problem again, we have theta equals nu Mach 2 minus nu Mach 1, or nu Mach 2 is equal to nu Mach 1 plus theta, so it is equal to 60.09 plus 15, which is equal to 75.09. Now we need to use the Prandtl-Meyer equation again for nu Mach 2. This time we know this value, which is 70.09, and we are going to use this same equation again to instead find here you have tan inverse of Mach 2 minus another tan inverse function of Mach 2. So what we need to do is we need to use this equation again when we know this value and we want to find the Mach 2 value. However, this is not a trivial thing to do. It's an implicit equation, so we can use the expansion fan tables where these values, these inverse values are provided, or we can use some software like maybe Mathematica or MATLAB. In either case, whatever you do, you'll see that the Mach value, which is calculated from nu of Mach 2, again like okay, I should have not erased that, using expansion tables or some software, is equal to hold on please, it is equal to 4.81. Now we need to use this value to find the pressure P2, and again you can see in that question, in the example problem, page number down in page number 875, you have this formula of since it's given in the book, I'll just write it, I'll just avoid writing the whole thing down again, but it is basically 1 plus k minus 1 by 2 ma2 square, and then on the function down, and then you have a minus k by k minus 1 outside, and you'll substitute these Mach values, the k value which is 1.4 again, and then you have a Mach 1 down, a function of Mach 1 down here, which is equal to 3.6. So on substituting these values, you will get this to be equal to 6.65 kilopascals. And again, in that same discussion, in page number 875, they tell us that we can find T2, the density, etc., with using the asymptotic relationship again. So I will write down the asymptotic relationship here for you. It is this. It is very similar to this above equation, but you won't have this factor term outside. Otherwise, okay, anyways, I'll just write it down here. T1 1 plus ma1 square k minus 1 by 2 divided by 1 plus Mach 2 square k minus 1 by 2. So on inserting the temperature, initial temperature which has been given to us, the initial Mach value which is given to us, the Mach second value which we calculated above, and then the k value which is 1.4, on substituting all of these, we get the temperature to be equal to 153 K.